Okay, now what we're going to look at in this lesson is writing some numbers as fractions, okay? This right here is what we call a mixed number, okay? So if a student had to do any multiplying or dividing of fractional amounts, mixed numbers have to be changed to what we call improper fractions. And this is how you go about it, and this should bring back some memories. Okay, you multiply and add here, and you put it over the same denominator. Okay, so we go 6 times 1 is 6, plus 5 is 11, so this becomes 11/6. Okay, those are equal amounts every day of the week. Those are the same amounts. Okay, this here is a whole number. Okay, and to write that as a fraction, we just place it over 1. Okay, so to write 49 as a fraction, we put 49 over 1. And once again, they're equal, just different ways to write the same number. Okay, now here we have a little tougher situation. We have to figure out the place value. Okay, and what I tell students, if you're struggling with place value, okay, think of how many zeros there are in 10, 100, 1,000, 10,000, and so on. That should help you to find the place value. The 6 is in the tens place. Okay, there's 1 0 in 10. Okay, so and the 2 is in the hundreds place. There's 2 zeros in 100. So the 5 then would be in the thousands place because there's 3 zeros in 1,000. And you know, I think that's a good method for finding place value if a student struggles with that a little bit. So when we write this now, okay, we write 3 as the whole number part of it, and then this part here, the fractional amount, is going to be 625 over, well, the place value, the last place value here is in the thousands place, so over 1,000. Okay, now, generally, then a student is going to have to write this in lowest terms. They're going to have to simplify it. Okay, and in this case here, hopefully they see that 25 goes into both of those numbers, and you can carry out the reducing steps and get the final answer in lowest terms. Okay, here is a situation now that is somewhat confusing, because this 5 repeats. Okay, there's a formula for writing this number as a fraction, but students aren't going to remember the formula. What I tell them, or the way I teach this, is I tell them, imagine writing it as without having this repetition bar. Okay, so this would be equal to 2 5/10 if you didn't have this repetition bar. But there's a repetition bar there, so we can't ignore it. Okay, because it's really not 2 5/10. The 5 repeats. Okay, but what it is then is anytime there's a repetition bar, you're going to take 1 away from this amount. Okay, so this is going to become 9. So our answer here is -2 5/9. Here's another example of the same principle. Okay, this would be like 36 over 100 if you wrote it without the repetition bar. Okay, so we got to take 1 away from that because there's a repetition bar, so this becomes 36 over 99. Okay, and this can be reduced, by the way. Hopefully students recognize that that 3 goes into them, and then they can go from there to get it in lowest terms further. Okay, now here is 3 different numbers, and students are going to be asked on their assignment on this lesson to classify these as either a rational number, a whole number, or an integer. Okay, now just to briefly talk about each one of those. A rational number is any number that can be written as a fraction. Okay, so if we take a look at -8, can -8 be written as a fraction? Okay, sure it can be, right? We could write this as -8 over 1. Okay, so it's a rational number. All right, so that's that part of it. Okay, integer. Is it an integer? Well, an integer by definition is all the positive numbers and their opposites. So 0, 1, 2, 3, 4, and then their opposites would be -1, -2, -3, and certainly -8 falls into that category, so it is an integer. Is it a whole number? Well, the whole numbers are 0, 1, 2, 3, 4. It is not a whole number because it's negative. So it would be a rational number, and it would also be an integer. All right, 1 and 5/9. Okay, well, let's go back to our definitions. Can it be written as a fraction to determine if it's a rational number? Well, certainly, it's in fraction form right now, so it's certainly a rational number. Okay, is it an integer? Remember, 0, 1, 2, 3, and their opposites, -1, -2. No, because it's a fractional amount, so no. And is it a whole number? Obviously not. Whole numbers 0, 1, 2, 3, and so on. Okay, so this one would just be rational. How about this case here? Now we have something that does not repeat, does not terminate. It looks like it's going to continue to go in a little pattern here. 3.14, 15, 16, probably 17, 18. Okay, we can estimate or kind of figure out the pattern. But this is an example of what is called the irrational number. IRRATIONAL. Okay, this does not repeat and it does not terminate. Okay, so this is classified as an irrational number. That's another term in the mix there. So we had rational numbers and irrational numbers, along that line. Okay, and I think that does it.